Hello, this is Team 66 presenting the EMAR medication management app. Our team includes me, Akil Chankola. I primarily worked on the back end. Rohan.
Hi, everyone. My name is Rohan Bilal, and I primarily work on the back end as well.
Hi, my name is Prithvi, and I primarily worked on front-end integration.
Hi, my name is Dhruv, and I worked on mainly the DevOps and some other full stack aspects as well.
I'm excited to share our project, an open source electronic medication administration record system, or otherwise known as EMAR. Let's start off with the problem. A lot of hospitals and clinics still use paper or outdated systems to track patient health and records. This can lead to mistakes like missed doses, wrong medications, or bad record keeping. Some digital systems are also old, hard to update, and locked behind expensive licenses. Our solution is to create an open source, digitized version of this record system. It's using the FHIR standard, which is used worldwide to make healthcare data work together. We use Spring Boot and the Happy FHIR client to connect to FHIR servers, and this lets us handle patient and medication data in a reliable and consistent way. With our system, you can create, manage patient practitioner profiles, link practitioners to their patients, prescribe medications with detail like doses, status, and quantity, or view or remove medications from patients' profiles. There's also other features like observations and different patient and practitioner and provider interactions included in the application. Everything is handled through an easy to use web interface that uses REST APIs on the back end. What makes our project special is that it's an open source and easily updatable groundwork for future applications to be built upon.
Our project is hosted on AWS. The website that after we build it is hosted on S3 and serves statically as a static website. The Spring service is hosted on EC2 and deployed via Elastic Beanstalk, which is very simple and easy to configure and offers like a really simple way to deploy new iterations of our service. And then finally, because the HAPI FHIR server, we generally test locally with a Docker container. We instead host this image in ECS on a Fargate instance. So this is running on a serverless cluster and exposed via an application load balancer. So I'll just quickly also go through the console to show all the different resources that we've used. So as I mentioned earlier, for the front end, we are hosting all of the generated or whatever we have typed out in HTML and CSS, as well as the generated JavaScript artifacts as well. These are all hosted in the EMR front end, and these are also exposed behind this HTTP like endpoint resource. So S3 will take care of all of our like front end needs. And for the Spring service written in Java, what we've done is we spun up like one EC2 instance, and via like Elastic Beanstalk, we are able to build our WAR file and then upload this WAR file into Beanstalk. And then what we'll do internally is start this instance as well as then run the Spring server on that instance and expose it on whatever port we have configured. And finally, the last backend call from between the HAPI FHIR service as well as our Spring service, we have an AOB that directs our calls to this running service, which is simply just the same local container. So this container is running on Fargate, as I've mentioned. It's serverless and will, for now, we don't have any like multiple tasks running. It's just simply one small task because we don't want to incur a large cost. In order to deploy or simplify some of the deployments as well, for the Elastic Beanstalk, it's simple to just simply click upload and upload the WAR artifact that we generate. But for things like S3, as well as the Fargate service, all of these steps that we need to build and deploy those resources, we've also generated, or we've written some scripts to automate those processes. So this script here will simply build the Angular application, and then via the AWS CLI, we'll just update or delete the existing resources in the S3 bucket and then upload the new web page onto the bucket. And then as well as for the HAPA Fire instance, what we've done is written a CDK script to through infrastructure as code. We just simply define the stack, define all the resources, and then through CDK we can deploy from local onto our AWS account as well. So this is how we host and test our application, and as well as how we're able to integrate every new change as well. I'm done.
Start.
The references that we generally use for this were primarily the HAPI, FHIR documentation pages. Our research was heavily focused on mostly integrating the local models that we built along with our CRUD operations and our controller and service architecture with a larger FHIR service setup. So the most difficult thing that we had to do that we really needed references and research for was accommodating medication requests with our local medication models and being able to integrate them with ownership of the patient so that they can make choices for themselves.
Hello, welcome to our application, our EMAR application for keeping track of medication health records for a patient. Right now, what you guys are seeing is our home page where we can create a provider, create a practitioner, create a patient, but also log in with either a patient or a provider. And our application is deployed on AWS S3, so that's where this homepage is running on. And then we also have a HAPI Fire server that is also deployed to AWS on a Elastic Bean server, and that's going to be keeping track of all the medication-related fire standard data. So in this video, I'll be going over a quick demo of our application and the different functionalities that it allows. So, and as you can see, I also have a network tab over here open, so we can see the calls that are being made to our AWS servers and the responses that we get back. So let's start with creating a new practitioner. We can just give like a random name, Steve Smith. And we'll just give a random phone number here. Cool. And we can now hit create. And as you can see, we get a response here. Successfully created practitioner with ID this. So I'm going to copy that ID because it's going to be important. And I'm going to save it here for now because we'll definitely need it later. But you have this ID, and you can see in our network call, we make a call to our backend Elastic Bean server that has our HAPI Fire instance, and we're making a post request for a new practitioner. Then we get a successful response with ID. So now if we go to provider login and we give that ID that we just got back, we can log in and we can see the user, Steve Smith, with the phone number. And right here we can see patients. However, this particular user does not have any patients yet, as we have just created them. So let's go on home, and now we can go to the create patient functionality so we can get some patients going. So again, we'll just create a random user here. John, let's just know, with random phone number again. Cool. In a similar fashion, we will hit create here, and we get a patient with a new ID here. And similarly, a call is made. Just to show you guys once again, we create a post request for this patient, and we get an ID. So let me save this ID here. Cool. So now let's go to patient login. We give that ID that we just retrieved, login. So as you can see, this is patient details page for John Stowe, the user that we created. Now we have an option to select a general practitioner, since this is a newly created user, does not have any practitioner assigned yet. So this is empty, and obviously no medications yet, as no medications have been assigned. But we can assign a particular practitioner, and we have a call here to get a list of all the available practitioners. So if we were to go through here, we can see all of these people available. So as you can see, Dr. Steve Smith, the one that was just created before, we can select that and hit assign, and that assigns a general practitioner to this patient. So now if we go back to home and we retrieve that ID that we got before for provider or practitioner, we log in with that ID once again, hit login, and this time we can see a list of patients. John Snow was added this doctor or practitioner to their profile, so now we can see the list of patients. So from here we can click on John Snow, and in a similar fashion to what we saw before, we can see the details of this particular user, but now we have the option to add medicine, and we have a list of medications that we have loaded prior to our Happy Fire instance. So we can assign a particular medicine for this patient for them to be able to view later. So one flaw we do have is that when it doesn't reflect right away, something that we will hopefully fix in the near future. But as you can see, like we do get a successful response when we try to assign this medication to this patient. So the changes will get reflected. So now if we were to go back and log in with that patient, we should see that medication right here. Yep. And this was assigned by that doctor, and it can be seen here. If we were to go back to the provider with that ID and click on the user, we can see it here as well now. And yeah, so we can assign more medications. And then there's also this delete functionality that we have here. The delete is working where it gets reflected right away. But yeah, this is our application. Yeah, thanks for tuning in.
There are two types of future work that we looked at when analyzing the strengths and weaknesses and where we could go from here. There is immediate future work that we can do. We did begin working on some observation notes that can be integrated with our platform, but we chose to leave those out because they didn't seem as essential. Another important thing that we intended to do was attempt user authentication so that patients would have more responsible guaranteed access to their own login information, their profiles, their medications, etc. The longer term developments of our project would require a architectural scaling. Right now we have a very manual setup of providers and patients logging in, but we would like to integrate more into an automated process. But this would require integration with insurance as well as local practices, which is a far more difficult and advanced step, but it is definitely something that this product has the capability to adapt to. The future of this has a lot of potential because there's both supply and demand, there's patients and providers. But this is not something that can grow one patient provider at a time. It would need to take a larger leap and bound, which is where this project could potentially go next.